Unit 13 Study Guide. On the first part, it's asking you to simplify radicals. So you would need to know those first 12 perfect squares listed there. When you simplify a radical, remember that you're taking the square root of all perfect squares. So on the first one, the square root of 25 is 5, the square root of 100 is 10, and that can simplify to 1/2. Square root of 24, that is not a perfect square. So you want to divide by the largest perfect square if possible. 24 is divisible by 4 and 6, and 4 is a perfect square. So in simplifying that, you would get 2 square root of 6. Square root of 50. The largest perfect square that goes into 50, not 49, not 36, but 25. 25 times 2. When I take the square root of 25, I get 5, so my final answer is 5 square root of 2. Square root of 7 divided by square root of 5. Neither one of those are perfect squares, and I can't leave a radical in the denominator, so I need to rationalize it by multiplying square root of 5 to the numerator and the denominator. When I do that, my numerator is square root of 35, which I cannot simplify, and I get square root of 25, which simplifies to 5. Square root of 35 over 5 is your final answer. Square root of 9 divided by square root of 5. Square root of 9 is 3, and I can't have a square root in the denominator, so I'm going to multiply the numerator and denominator square root of 5. I can simplify that to 3 square root of 5 divided by 5. Square root of 32. Again, always trying to look and see if there's a perfect square that it is divisible by, and that is 16. Square root of 16 times the square root of 2. The square root of 16 is 4, so our final answer is 4 square root of 2. Square root of 75. If you haven't been, it's easy to look at the perfect square list and see where 75 would fit, which is between 64 and 81, and then you're going to move down to see if any of those fit in or are divisible to the number. So the largest perfect square that goes into 75 is 25. 25 times 3, so I can simplify that to 5 square root of 3. And 21 is 7 times 3, but neither one of those are perfect squares, so square root of 21 can't simplify. Concept 1460, operations, simplify the radical. Remember, when you've got a squared, it's like using the distributive property. So we need to take 3 squared times the square root of 7 squared. 3 squared is 9, and squared and square root undo each other, so that actually leaves us with 7, and 9 times 7 is 63. When you're subtracting, you need to have the same number under the radical. So we need to see if we can simplify the square root of 20, which we can. 20 is factored by 4 and 5. 4 is a perfect square, so I'm going to simplify that to be 2 square root of 5. So I have 7 square root of 5 minus 2 square root of 5, which is going to simplify to 5 square root of 5. When multiplying, you're going to multiply the like terms. For example, you're going to take 2 times 4 to get 8, and you're going to take square root of 10 times square root of 2 to get 20. We can simplify the square root of 20. Again, 4 times 5 is 20, so we'll take the square root of those if possible. That's going to leave us with 8 times 2 times the square root of 5, or our final answer, 16 square root of 5. On the last one, you can see that these already have the same number in the radical sign, so I can just add my like terms, which 5 plus 8 is 13, so my final answer is 13 square root of 2. On the last concept, we're talking about solving quadratic with radicals and using the Pythagorean theorem. The first one, x squared plus 8 squared equals 10 squared. Simplify all of those to give us x squared plus 64 equals 100. Solve this now like a two-step equation. Subtract 64 on each side, and x squared equals 36. To get rid of the squared sign, we need to take the square root of each side, so x equals positive or negative 6. 3 squared is 9, plus x squared equals 4 squared or 16. We'll do subtraction to get 9 Over to the other side, which leaves us with x squared equals 7. Take the square root of each side, and x is positive or negative square root of 7. You can't simplify that. 3 squared plus 4 squared equals x squared. Simplify what you can. 9 plus 16 equals x squared, which is 25 equals x squared. Take the square root of each side, and x is positive or negative 5. On the next one, we have x squared plus x squared equals 10 squared. This one's a little harder, it looks or appears to be, but let's work through this together. I'm going to add a 1 in front of each of those, so it's really going to be 1x squared plus 1x squared, which now looks more like terms you can simplify or combine. So 1x squared plus 1x squared gives me 2x squared, and 10 squared is 100. From here, I'm going to divide both sides by 2, and x squared equals 50. Then I'm going to take the square root of each side. When I take the square root of 50, I have to break that down and simplify that. So the square root of 50 simplifies to the square root of 25 times 2, which gives me x equals plus or minus 5 square root of 2. On the next one, sorry about that, 5 squared plus x squared equals 6 squared. So 25 plus x squared equals 36. You want to subtract 25 from each side, and x squared equals 11. Take the square root of each side, and x equals positive or negative square root of 11 because it can't be simplified. The last problem here, 3 square root 5 squared. So distribute that squared, so it will be 3 squared times the square root of 5 squared plus 2 squared. If I simplify that, 3 squared is 9. 9 times 5 plus 4. 9 times 5 is 45. 45 plus 4 is 49. So 49 equals x squared. You need to take the square root of each side, and x equals positive or negative 7. In the final question, we've got a word problem. A right triangle has a leg of 5 and a hypotenuse of 8. Write an equation that would find the missing leg, then solve. So I would draw a picture and label my triangle. Remember, hypotenuse is the angle, the side length that's across from the 90-degree angle. So when I write that in my formula, it's going to be 5 squared plus x squared equals 8 squared. When I simplify that, x squared plus 25 equals 64. I'm going to subtract 25 from each side and get x squared is equal to 39. 39 doesn't have any perfect squares that it's divisible by, so we're going to take the square root of each side, and x equals positive or negative square root of 39. Because we're talking about distance or a side length, we're just going to have the positive of x equals square root 39. Make sure that you're ready for your quiz or your test over this unit. If you have any questions, please make sure you see a teacher.